Hello class, in this video we're going to be looking at the correlation between two variables. The learning intention of this video is for us to learn how to comment on the relationship between two variables. The word correlation or association is used to describe the way in which two variables are related. So if you're looking on the scatter plot on the right hand side, we can clearly see that there is some kind of relationship or correlation between the temperature and the number of cells generated. When we are asked to comment and describe the correlation between two variables, we do so by commenting on the direction, form, and strength of the relationship as shown on my flowchart over here. I would highly recommend that you copy down the flowchart on the right hand side, as this is a good summary and this will help you remember how you should be writing your responses when you're asked to comment on the correlation. I want to talk about this in a bit more detail in the future slides, but when you're asked to comment on the direction, you're going to be saying whether it is positive, negative, or has no correlation whatsoever. When you're addressing the form of the correlation, you're talking about whether it's linear or non-linear. And lastly, for the strength, you're identifying whether it's a weak, moderate, or a strong relationship. Let's look at this in a bit more detail. So when you're talking about the direction of the correlation, this could either be positive, negative, or neither, which means no correlation. A positive correlation or a positive association is characterized where an increase in one variable also increases the other variable. So a real life example of this would be as the temperature increases, the ice cream sales will also increase as well. In contrast, a negative correlation is characterized where one set of value increases, but this actually decreases the other variable. So a real life example would be as you increase the temperature, the number of hamburger sales going down. An example of having no correlation would be whereby the temperature increases, but this doesn't actually change the number of coffee sales generated. When you've got a scatter plot with no correlation, you'll find that the data points are randomly scattered from one another and there is no visible pattern at all. In addition to the direction of the correlation, we also need to specify the form of the correlation. The form of the correlation is related to the shape, and we simply need to state whether it has a linear or non-linear shape. As the name implies, a linear relationship is one where the points in the scatter plot falls around a straight line, whereas a non-linear relationship takes on a curved shape. For linear relationships, you should be able to draw a line of best fit, and you can think of that as a line that summarizes the dataset and shows a relatively constant trend. So therefore, I could draw my line of best fit like this for the very first diagram, whereas in each of the other examples, you can see that this takes on more of a curved shape. The last thing that we need to address when talking about the correlation is the strength. So the strength of the correlation can be described as weak, moderate, or strong, and there are two ways in order for us to determine the strength of the correlation. One of the ways in which we can identify the strength of the correlation is by examining the density and position of each of the data points in the scatter plot and comparing its distance to the line of best fit if it's not drawn. So in each of these examples, the line of best fit is drawn for you, but you could also draw this yourself. And as you can see, when you've got a strong relationship, whether it is positive or negative, notice how each of these points are closely positioned to the line of best fit. And as you can see, they are a lot more compact and closer to one another. As you progressively increase the distance away from each other, so away from each data point as well as the line of best fit, then you're going to get a more weaker correlation. When you're commenting on the strength of the correlation using this method, it can actually be subjective and inaccurate, as my interpretation may vary from your interpretation, particularly when you're dealing with a moderate relationship, okay? A better way or a more accurate way of finding out the strength of the correlation is by calculating the Pearson's correlation coefficient, and we're going to learn how to do this in the next lesson. But for the purposes of this video, we're going to stick to the first method. So let's go through a couple of examples. To help you comment on the correlation between the two variables, I would like you to please refer to the template I have over here to formulate your responses. Let me show you how to use this template in the example down below. In this particular scatter plot, notice that each of these values are very close and condensed to the line of best fit. So therefore, I know that this is going to be a strong relationship. I also know that this is going to be positive because as the temperature increases, the sales also increases as well. And each of these values also follows a linear trend as well. And all I need to do now is to identify what is my explanatory variable and my response variable. So explanatory variable being temperature and response variable being sales. So therefore, if I was to articulate a response using the template, it would be like this. Let's have a go with another example. So in this particular example, notice that the line of best fit isn't drawn for you, but in this case, it might be useful for you to include a line of best fit. So remember, a line of best fit kind of roughly runs through the center as it's a very nice summary or average of the overall data set. So therefore, in this case over here, my line of best fit may look something like this. In this particular example, I could see that the values are kind of scattered away from one another and are not close to the line of best fit at all. So therefore, in this case, I'm going to characterize this as a weak correlation. I also can say that this is going to be a negative correlation because as drug dose increases, the response time decreases. So that's a characteristic of a negative relationship. And in this case over here, it also does roughly follow a linear relationship as well. So therefore, I'm going to comment as that. And therefore, again, just identify what is your EV and RV. Therefore, your response should look like this. Let's now have a go at answering a few questions. In this question, you want to select the correct option, which provides the correct descriptions for the direction, form, and strength when you're commenting on the correlation. The correct answer for this question is going to be C. The next question is going to ask you, what is the correct description about the relationship between the height and weight? In this particular scatter plot, I can see that as height increases, the weight also increases. So therefore, this is going to be an example of a positive relationship. The next question wants you to now use a template so that you can describe the correlation in terms of the direction, form, and strength. In this particular example over here, you can kind of see that there is going to be a negative relationship because you can kind of draw a line going down like this. You could also see that each of these values also follows a linear relationship because they follow around this general trend line. And in terms of the strength, their values are not very close to one another at all and further away from the line's best fit. So therefore, I'm going to characterize this as a weak relationship. So therefore, when I'm trying to write my overall report, I'm going to say the scatter plot suggests a weak negative linear relationship between the two variables. To get further practice, I would now like you to please answer questions from exercise 7C. This is the end of the video. Thank you for watching and I'll see you guys again in the next video. Bye.